get started.
Okay, I got it set up camera-wise. I'm hoping you have a full view of everything on here. And now it may not be very well to see, but I'm hoping you can. The situation with the harness is, one, these are too long, and it pushes the tender way back from the engine. But in order to make them shorter, you can't just make them short. You have to have compliance because you're going to make a turn on the radius and blah, blah, blah. Plus you have to fit it into some other requirements. So what I'm going to do is take this off and show you what it looks like, and then show you my new design so you can get an idea of the new harness for this particular. What the heck? Who put that in there? I must have. That's sad. Well, we're changing that. I put in a goofy screw. Okay. Now then, we still have our soundboard plugged in, so we unplug it by coming out towards the front. There, and a little more. There, and a little more. And there. Okay, good. Unplugged. Now you can see the back. There's a little complexity there. This plugs in here like this, and the red is the hot. So in this case, this red here is the positive on this board. The red here is the positive on this board. Margaret should answer that. I'm not. I'm busy. Then these two here are motor control, and these two here are chuff trigger. I have red on it, but it doesn't matter. Okay. Then the next thing I need to do is bring up the outlets, and those holes have been modified by me. Those are not the standard holes. I have a frameless standard holes I'll show you later, but currently they're just single hole. Okay. So this is the speaker, and this is the baffle, and this is the interface to the engine plugging in here, and then the tender plugging in here, tender stuff, all this stuff that's loaded in the tender, and then these go to the engine. All right, and I need to have a better design. I need to have more accuracy and all kinds of problems. So what I'm going to do is take this off, if I can. It's little screws are sometimes a little finicky. You just have to use a little muscle. Okay. So this is the harness that I'm trying to work. This is the standard chassis that I had used, and I did have a slot for these wires to go down through. And this board would sit just about here, so the wires would go down, and then they would be allowed to go. So if you had a turn, they would be allowed to move over like this or like this a little bit, which I thought was probably enough. Then I found that problem was the ability to have enough slack. It wasn't moving, and it was hard to install through there, and I had to solder them here, and it was just turned into a mess. So for the prototype purposes, I drilled a pair of holes so this thing would sit here, and it actually pokes through those holes. But then when I did that, it sort of gets in that hole and stays there. So when you make that turn, now they stay out there, and then they get pulled. And it got tight. So I had to leave them long in order to make that work. My final design, the one I have been building and shipping now, is a pair of holes like this. So it sits here and it sits out here, but now as I make that turn, I really don't have any movement. I can't bring it over like this at all. So you can see what that little bit helps with. So one of my thinkings, not today, but maybe in another build, is to take this part like this and either move the holes more near the center like here, or maybe change it to an oval like this, or maybe really follow this radius, right? Make it do what I had, only just make it a bigger opening with more room. So I kind of go back to this idea, but oversize it. Go up here, go down here, and give it a lot more opportunity to move. I think that might be the way to do it, and that might help alleviate this motion thing. But I still need to get the length correct and dimensioned properly, so that's all part of it. So as you can see, it bolts onto this fellow like this. It fits underneath like that, and then this bolts down here and here and the two edges, and once it's secured, then these guys plug in like I showed you, and these go down the hole and go forward. Okay, fine. But the other thing I wanted to point out was, if you look at this, these leads are crimped and put into a fixture, right? These leads are just soldered on, and so once they're soldered on and bolted to this board, that's it. They're fixed. You can't take them apart. You can't do anything, you know, it's just the way it is. Also, soldering them on doesn't end there, because this board has to be a real PC board in order to make it work. This pin here and the tip of the wire have to be continuity. They have to be touching. So you have to glob solder on them in this design, right? And then you have to drill these holes, and this takes as much as an hour to assemble. All right. So I wasn't happy with that. And plus you can't unplug the wires, and you don't want them to plug in because you worry if they're too loose, they'll just unplug while you're running the train. So I came up with a new idea and a new design using this sample piece, but this is a unmolested board. So I'm going to put in the pieces like I had, like this, maybe down here like that. Okay. Then what I want to do is take this, which I can't. Yeah, here we go. These are my real delicate pliers. There we go. And if I take this and solder this, just this fixture, okay, this unplugs. See that? So if I take this fixture and mount it right there, then I solder these two together, and then all I have to do is put the two solder, I had a board here, it is. It moved on me, okay. So these solder joints then become fairly simple. When I buy this PC board, I will build that track in when I buy it. But for now, all I have to do is bridge these two, these two, these two, these two. Just bridge them with a little bit of solder, and everything will be fine. Then this sticks out like this. And that's how you would assemble this. You would assemble it like this. So it would stick out on the inside, and it would stick out like this. Like that. Okay. Then you take this piece, and I came up with some means. I tried to come up with a way to hold it and then bolt it on. I meant like this, right? The challenge was this one was a little too small. I think this one was still a little too small. Yep. This one was probably getting closer, but I needed a way to make it work a little better. So, and then I did this one, and this one was not, oh, this one, oh yeah, this one worked out, but it was, I didn't like the way it went. Anyway, this is the one I chose. And what I do, the wires would come in here like this, and they come out the back, you see that, and he goes all the way in. He goes in like that, so it's recessed. So when this is sitting on the PC board like this, not that one, this one, he's sitting on the PC board like this. Yeah, like this, that's right. Just goes right on, okay. He sits like that, then this would plug in to the sockets and then encapsulate, and then look, you have a hole. Well, if I had put it up one, you'd see it. And one screw lines up on one side, and the other screw hole lines up on the other side. So you can actually put a screw through here and tie it into this board so that they're captured. The wires can't come out because this piece is wrapping around what's in the socket. If I can push this out, I should be able to get it. Yeah, there we go. It wraps around this edge here. It's a little smaller on the inside, and it prevents it from pulling all the way through. So it can't unplug. That's the trick. I didn't want it to unplug, and I wanted it to look like something that could actually fit in here and then be routed, still routed and still plugged in. Oh, I'm dumb. Don't listen to me. It goes like this. There, it goes like that. So when it sits like this, there's the wires coming out, and then they come out of here and they just go straight down like that. They go straight down. That's the idea, as they go straight down. But then what I want to do is go back to this design so they go straight down, but they have a big wide opening right there. So when they fit in the sit down mode, like right there, there we are, right there, and he lines up with that. You can see it's down, but the harness can move all the way over to here, all the way over to here, and this opening will be much bigger, so the cable won't be caught and pinched or anything. So that's what I'm going to be doing with that. But today, or this morning, what I need to work on is the length of wire, the exact length of wire to fit from here to there. The last number I came up with, and I went through all this housing, the shape of the piece, yeah, to build this shape, I had to go through dimensions of this design, the dimensions of the standoffs for the pins, and then come up with the cavity that I needed, and then I needed the screw. So I went through all that, and I had some shrinkage. That's why I have these up here. I had to go through, keep adding a few percent. Finally, I get what, if it shrinks down, what you need to print is ask for a 2.8, and you get a 2.6, something like that. So now I can print these guys, and everybody fits in and won't pull out. And these are soldered into that board, so that's a good fit. And that should be great. Oh, yes. So now I'm going to continue to build this out. I'm going to take this shape here. Let's try it here. Try it right here. Yeah, let's do it like that. That's that. Here's this. Those holes are here. So this thing is going to sit right here. The board's in back. So the board's in back. So the wire is right along that edge. So now the wire, the 4 wires will come out from there like that. So the 4 wires are going to be right there. So the opening should probably go like this. This will do it, and it should probably go like that. Yep, something like that. And then this one would be off in this direction, and then off in this direction, So it's going to be like that too. It's going to be fat here and then taper down as it goes to the back. So they're going to be like this. They're going to look like almonds, so to speak. Like an almond shape. Like that. Kinda. That's the idea. I think that's what they're going to look like. Yeah. And then the pin exit will be over here. Then the wires will come down, and then they can slide a little bit over here for that turn. And they can slide over here for that turn. And then going straight ahead, they'll be more or less like that. So you get the idea. We're trying to give them that much room, and it doesn't require that much. Really. We're only turning. This is the tightest piece of track that American Flyer makes, so you can set up on that, and you can see what radius you would need, and it's only that much. All right, so you only need to go about. Let's see. I don't think it's 20 degrees. I think it's 10. Let's see if that's 90. Yeah, it's less than 10. So you get 10 degrees. That's not much. So I don't think it's that big. Shouldn't be that difficult to fit it in and give us just enough room that we need. And I noticed my little lock-in piece popped off, so I'm going to have to. I tapered it. Now I'm thinking I may have to make it more stiff, a little more beef to hold on. Okay, so that's what I'm going to try to do this morning, is come up with the length, which my magic length at one point was 325 millimeters. That's what I thought I needed. Must be inches. Yeah, it must be inches. Must be inches, yeah. Good God. Okay, here's 3. Let's do it here. Let's do it here. See what we get. There's 325 right there. Oops, I'm off. Right there. Right there. If the pins are here, the end of the socket should be here, and that dimension should be 3¼ inches. Yeah, so if I'm sitting here, yeah, I'm sitting at 4.4, so that's 4.4 is there and 3.25 is there. I made his 3 in the last one I made, and they were too short, and I added 1 inch to them, so I made them 4 inches, and they were very long. So now I'm thinking I'm gonna have to get back to something like this, 3, 3.5, somewhere in this zone for this length, in order to have enough room to make those turns, and they're going to plug in the flat. That's the other part that's changing. So if they plug into flat like here, let's see if I can get one. This one sort of works. This is a whole modified thing. Don't worry about it. These are the clamps that go on here. So they clamp here, and that's there, and it ends there. Okay, so let's say it ends there, ends in the middle. Okay, right there. There's the cable. And that's just about, oh boy, that gap looks bad, doesn't it? Like 1¼ inch, which doesn't sound bad, 1¼ inch, but over almost 25, 26 millimeters. That really, I've been working in millimeters so much I'm beginning to see it all. Wow, okay. Well, what I'm going to do is I'm going to get a chassis, bolt this on, set it up, and I'll probably use my dummy, this one here, I guess, and see, you know, what can I get? How does it work? Maybe I won't use that one. Maybe I'll use this one and just hog it out, since I can't use it the way it is, but if I hog it out, I could at least use it. So if I hog it out according to these things, make that shape, that almond shape, points down, comes up, right, do that, hog this out, then bring this in, then put, oh, yeah, but you know what, yeah, I gotta put I gotta put wherever this pin is. Oh, it's way back. Oh my God, it's down here. I wonder if that's part of the problem too. If I added some material here, I could put it here. I wonder if that's the smarter move. Move the pivot further out, because it pivots here and here. And if you do the 10 degrees, if it's here and you do 10 degrees, ooh, you're gonna pull it in closer. More uniform. Well, I'll think about it. I'll do some tests. I'll show you what I've got, and we'll see what it looks like. The two things I'm trying to do is build a harness easier and simpler and faster and more accurate. And the second thing is making sure I maintain the compliance to make the turns. So I'll see what I can do with it. And I'll make another video later today and show you what I got. I didn't turn it back on.